Two-step equations. Example 1. In a series in an electrical circuit, the total voltage is 12 volts. In one resistor in the circuit, there is a drop in voltage of 4 volts. Find the resistance of the second resistor if you know the current is 3 amps. Use this equation below to help solve. So let's go over a few things before we solve for this. So when we are simplifying, we use order of operations and we multiply and divide before we add and subtract. But when we're solving, we work backwards and we add and subtract before we multiply and divide. So let's go look at back to our example to see how we solve for this. So here we have 3r plus 4 is equal to 12. Now we want to get r by itself. And so the first thing we do as we are solving is we're going to subtract 4 on both sides, because whatever we do to one side, we will do to the other. So this gets rid of 4 on the left-hand side as that becomes 0. So now we have 3r is equal to 12 minus 4, so that's 8. We're going to go ahead and first divide on 3 by both sides. So this 3 over 3 just becomes a 1. So now we have 8 over 3. So let's go ahead and solve. So we have 8 divided by 3, which is equal to 2 point, and we're going to round to the nearest hundredth, which is the second one. So we'll just go R is equal to 2.67 ohms as its resistance, and that would be our final answer. So let's go ahead and look at another example. Here we have, in a series electrical circuit, the total voltage is 12 volts. One resistor of the circuit has a voltage drop of 3 volts. Find the resistance of the second resistor if you know the current is 1.5 amps. We're going to use the equation below to solve. So we have 12 is equal to 3 plus 1.5 R. So the first thing we do is when solving, we will subtract. And so we're going to subtract on both sides. 3 minus 3 is equal to 0. Now we have 12 minus 3, which is equal to 9. And then we have plus, and we still have the 1.5 R. So let's just go ahead and write this as 9 is equal to 1.5 R. Now to undo multiplication, we divide. This just becomes 1s. And then we're going to divide on 1.5 on the other side. So we're going to go and go 9 divided by 1.5, and that's equal to 6. So R is equal to 6 ohms. And that would be our final solution. Now, if we want to verify that we did this right, we would go 12 is equal to, so we have 3 plus 1.5, and then instead of putting R, we're going to put 6. So now we have 6. So let's go ahead and check to make sure we get 12 on this other side. So we have 6 times 1.5, which is equal to 9. So 3 plus 9. So then that means we get 12 on both sides. So we know that we got the correct solution. So that is how you could check to make sure you got the right answer. Now let's go look at another example. Example 3. Solve for the following. We have 2x plus 8 is equal to 13. Let's go ahead and write that. So the first thing we do is we're going to subtract on both sides. This gets rid of the 8 on the left-hand side, so we're just left with 2x Now 13 minus 8 is equal to 5. Now to undo multiplication, we divide. So that gets rid of it right here. And then we're going to divide by 2 on the other side. So we get 5 divided by 2, which is equal to 2.5. And that would be our final solution. Let's do one more example. So we have 6x minus 4 is equal to 21. So we have 6x minus 4 is equal to 21. So the first thing we do is we're going to add 4 to both sides. This gets rid of the 4 here. We're left with 6x. Now we have 21 plus 4, which is 25. Now to undo multiplication, we divide on both sides. So we get 25 divided by 6, which is equal to 4.17, as we're going to round to the nearest hundredth. So x is equal to 4.17, and that would be our final solution.